Hello, ladies and gentlemen. This is Mr. Robeson here. We are working on 7.2 today, hypothesis test for proportions. We're going to go over how to check the conditions. So last class, we went over how to write the hypothesis for both means and proportions. For now on, we're just going to really be focusing on proportions. All right, it's the easier of the two. So when we're doing hypothesis test for proportions, there are three conditions that we have to check. The first condition is, do we have a random sample? So our information must come from a random sample to be as unbiased as possible. So we don't want bias to creep into our experiment, because if it's biased, it's going to throw off all the results. All right, so what we really do is we just look through the information that's given, or if you're doing the actual sample taking yourself, you make sure you take a random sample. And if it is a random sample, you're just going to write down random sample stated. If not, you're going to say not a random sample, and we're just going to stop. All right, the second condition, number 2. We need to have a normal sampling distribution. All right, so our sampling distribution must be normal so that we can apply the rules of normal probability to it. So we're going to be doing like normal CDF or inverse norm type things for this. We have to do one or the other when we do these later on. So we have to have a normal sampling distribution. So if we're working with proportions, there's two conditions that we have to check for there. N times P has to be greater than or equal to 10. And n times 1 minus p has to be greater than or equal to 10. And this p naught means this p is coming from our null hypothesis. So remember our null hypothesis, we're saying p equals some value. Well, that value is p naught. That's what we use, not our sample information, but the null hypothesis, what we start off believing. If both of these are true, then we're good. We just say check, normal sampling distribution, we move on. If one of them fails or both of them fail, we stop. Like if one of these is like 5 or 7 or 6 or something less than 10, we're going to stop and say it doesn't work. All right. Our third condition that we're going to check is independence. So the elements of our sample must be independent of each other so that we can use standard deviation formula that comes along with a sampling distribution. So remember this standard deviation formula, it's the square root of p times 1 minus p over n. We can only use that if we have independent, it comes from an independent sample. So the way we check this, either we need a randomized experiment, in which case we can just say we have a randomized experiment instead of a randomized sample, and that covers both of these conditions. Or we need our sample size to be less than 10% of the population. So our sample size will be n, and we just check, is it less than 10% of what the population size could possibly be? So we just estimate, we just kind of eyeball it and say, yeah, that seems like a reasonable guess. All right, let's try it. So again, here are 3 conditions. I kind of shortened them here, but those are them. And let's see, checking the conditions here. So Mr. Robeson claimed that he makes 80% of his shots in trash ball. You think he makes less than 80% of his shots. In a random sample of 52 shots, he made 32. State your hypotheses and check the conditions. All right, so our hypotheses are, we start out believing what we're told, that P equals 80%. Our alternative is we said that he makes less. We think P is less than 80%, where P is the true proportion. So we still have to do all of this stuff that we were doing before of shots he makes. All right, so that part still applies. We still do all that. Now we check our conditions. Did it say random sample? Yeah, random sample right there. So for the conditions, we're going to say random sample stated. Check. All right. If we want to bullet point these, you can. If you want to call them 1, 2, and 3, you can. All right. Random sample stated. Next one, number 2, our normal sampling distribution. So our P naught is this guy right here, 0.80, and our N is 50. So N is 50. P naught equals 0.80. So we're going to check these 2 conditions. So first we need n times p naught. So 50 times 0.80. So 0.8 times 5 is 4, so 40. Is that greater than or equal to 10? Sure is. What about n times 1 minus p naught? So that's 50 times 1 minus 0.80, which is 0.20 times 50 is exactly 10, which just makes the cut, because it's equal to 10. It works. If it was less than 10, we'd say no, and we would stop. All right, and lastly, independence. So I usually write out independence. Oh, and I should probably write normal check here. So this condition worked out. So it is normal. Check. Independence. So our n equals 50. Is that less than 10% of all possible trash ball shots? All right, well, if we just multiply this 50 by 10, then we would need to have at least 500 shots. Is it reasonable to think that we could have at least 500 shots, that Mr. Robeson could sit and take 500 shots? I mean, he could. Probably in his lifetime, he's already taken more than that. So yes, that's reasonable to believe. All right, so that's how the independence one works. We just take this number, multiply it by 10, and we say it's reasonable to believe that we have more than that. All right, let's try some more here. So according to the U.S. Census Bureau, the proportion of students in high school who have a part-time job is 0.25 or 25%. An administrator at a local high school suspects the proportion of students at her school who have a part-time job is less than the national figure. She would like to carry out a hypothesis test. The administration selects a random sample of 200 students from her school and finds that 39 of them have a part-time job. So what does the parameter stand for, and what are the hypotheses first? Well, our parameter P is the true proportion of students with a part-time job. All right, so our null hypothesis, we start out believing the Census Bureau here, that the proportion is 0.25. So that's our P naught. All right, and our alternative is we thought it was less than for this school. So we think P is less than 0.25. All right, now our conditions that we have to check. So first off, do we have a random sample? Yeah, right there. So random sample stated. Check. Next up, normal. I'm just going to start off writing normal. Well, our n here is 200. Our p naught is 0.25. So 200 times 0.25, 25% of 200 is 50. That's greater than 10. The other one, 200 times 1 minus 0.25 is 0.75. 200 times 200 is 150, which is also greater than or equal to 10. So this checks out. Both of them work, we're good. If one of them doesn't work, we stop. And we say it doesn't work. All right, lastly, independence. So our sample size is 200. We need that to be less than 10% of all students at that high school. So that works only if, well, 10 times 200 is 2,000. So that only works if we have 2,000 or more students at the high school. So hopefully we do. I don't know, did it say large high school? Maybe. Local high school. Well, hopefully it's a large school. All right, so that's it. That's all we're doing for today. All right, so one more example here. So according to the last conducted survey, 68% of people in California believe in human-caused climate change. You would like to perform a hypothesis test to see if the number has increased since the last survey. You take a random sample, and increased is probably important, of 400 people, and 298 of them say they believe in human-caused climate change. So what does our parameter stand for, and what's our hypothesis? So we're working with a percent, so it's a P, and this is the true proportion of, and this is people in California that believe in human-caused climate change. So of people in California who believe in human-caused climate change. All right, so our null hypothesis is, from the last information we got, that the true proportion is 68%. Our alternative hypothesis, we want to see, has it increased? Like, that was the key word. So that means our P is going to be greater than 68, we think. And here's a graph of solar activity in yellow and temperature in red. So solar activity is clearly not what's causing the temperature to continue to rise every year. All right, so now we plan by checking the conditions. So the first one is, do we have a random sample? Random sample. So we go back up here and you said, yep, you take a random sample. So random sample is stated. If it was not stated, we stop and say no, not stated. All right, next one, the normal condition. So our N is 400 total people. That's always the bigger of the two numbers. Our P naught was our null hypothesis here, 0.68. So 400 times 0.68 and 400 times 1 minus 0.68. And we want to see, are those greater than or equal to 10? So I don't know those numbers off the top of my head, so I'm going to pull out my calculator. And there we go. So 400 times 0.68. 272. So the other one's going to be, what, 138? So these two numbers always have to add up to the end, but let's go ahead and calculate the other one. 400 times 1 minus 0.68. If you're going to do this on your phone, do the 1 minus 0.68 first, and then take that answer times 400. So we get 272 and 128. Both of those are easily bigger than 10. So both of those check out. So the normal condition, it works. Finally, independence. So our N was 400 people. Hopefully that is less than 10% of, and this was people in California that we were asking. So 10% of all people in California. So we know there's more than, let's see, if we just do that times 10, we know there is definitely more than 4,000 people in California. There's something like 30 some odd million of them. So we're good there. So all three conditions check out for that guy. All right, so that is it for checking the conditions. So check on the homework where, again, you're just going to practice checking the conditions and writing the hypotheses.